Okay, let's look at the set part of the 1.4 homework. And remember that this is going to be the thinking part of the homework, because this is going to be like the task that we did in class. So if you remember, we were doing a pen for rabbits in class, and we were saying, okay, well, what could the perimeter be that would maximize the area? So this is going to be the same kind of thing. Adam and his brother are responsible for feeding their horses. In the spring and summer, the horses graze in an unfenced pasture. The brothers have erected a portable fence to corral the horses in a grazing area. Each day the horses eat all the grass inside the fence. Then the boys move the fence to a new area where the grass is long and green, and the brothers have always arranged the fence in a long rectangle that's 10 by 70 feet with an area of 700. Adam has learned that in his math class that a rectangle can have the same perimeter but different areas. So he's beginning to wonder if he can make this daily job easier by rearranging the fence so that the horses have a bigger grazing area. He begins to make a table of values. He lists the areas with a perimeter of 160. So let's just look at what this is explaining. Currently, they have it as 10 by 70. And if I add that all up, sorry, these zeros don't look like zeros. Hang on. 70 plus 70 is 140, 150, 160. You can see that the perimeter of the whole thing is 160. And same thing, I could make it the long ways where it's 70 by 10. And that also equals to 160. Well, they're saying, what if we changed those dimensions? What if we made it 20 on the side instead of 10? So that would use 20, and 20 is 40. And so then on these edges, it would have to be 60 and 60, because that makes up 120 plus 40 is 160 for the same perimeter. So even though this one up here, 70 times 10 was 700 square feet, this one right here, 6 times 2, do you see how this would be 1,200 square feet? So this one would have more grass for the animals to eat. And so that's what they're thinking. They're thinking, what if we change the dimensions so that we would have a greater area inside? And so we go down to this table of values. So here's the one we were just talking about, 20 by 60. And notice that these are all going to have the same perimeter right here. They're all going to have to add up to the 160 the whole way down, but the areas are going to change. So for example, 20 times 60, we just calculated that on the page before, at 1,200 feet squared. Likewise, we could make it 30 by 50. Notice that for every 10 I go up here, I go down 10 there. Okay, so 3 times 5 is 15, and add the 2 zeros. 40 by 40 would be 1,600 feet squared. Now we start to repeat. 50 by 30, 60 by 20, and 70 by 10. All right, discuss Adam's findings. Explain how you would arrange the fence so that he would be able to do less work. So do you see this one right here that has the maximum area? We would say, I would make the dimensions 40 by 40. So we had maximum area for grazing. I don't know, write it in your own words, but you get the point here. They want us to find that maximum area. Make a graph of Adam's investigation. Let the length be the independent variable and area be the dependent variable. So we're really going